Let's take one more look at this example. Now, we found U cross V. What I'd like to do now is I want to find V cross U. What happens if we flip the order of the vectors here? So vector V was, what was vector V? 2, -1, 2. I'm going to take the cross product of that with vector U, and vector U was -4, 0, 1. So we're going to take the cross product here the same way. So I'm going to put the vectors in a determinant where the first row of the matrix I'm taking the determinant of are the standard unit vectors I, j, k. The next row are the components of the first vector in the cross product. And the second and the last row of the matrix is the second vector I'm taking the cross product of. Okay, so you just go in order. The first vector goes first. The second vector goes next. Okay, and I'm going to move a little faster on this cross product just because we've seen it once before. Okay, so I'm going to worry about the I component first. I imagine canceling out the row and column with I in it. I'd be left with -1 minus 0 is the 2 by 2 determinant left over, so I get -1. Okay. Next, the j component. Imagine canceling out the row and column with the j in it. I'd be left with the determinant of the matrix 2, 2, -4, 1. The determinant of that 2 by 2 matrix is 2 minus 8. I'm sorry, 2 minus -8. 2 minus -8 is 10. Finally, the k. I imagine canceling out the row and column with the k in it. I'd be left with the 2 by 2 matrix 2, -1, -4, 0. If I take the determinant of that, I get 0 minus 4, so I get -4. Alternate signs, plus, minus, plus. And I get -1 times I minus 10j minus 4k. Or -1, -10, -4. Okay, that's V cross U. I want you to compare that with U cross V. U cross V is 1, 10, 4. Notice they are not the same. But it's not like they're totally different. They definitely have a relationship. Flipping the vector seemed to just flip the sign of the components, right? U cross V is equal to the negative of V cross U. Again, this isn't just some quirk of this particular problem. It's a general property of the cross product. Let's add to our list of theorems here for the cross product. Let U and V be three-dimensional vectors. Then the cross product is anti-commutative. Product is anti-commutative. If I take the cross product of U cross V, that is equal to the negative of v cross u. That is, if I commute the two vectors, if I commute u and v, so if I flip them around, I get the negative of what I started with. So it's not commutative, because if I flip them around, I don't just get the same thing. It's anti-commutative. If I flip them around, I get the exact opposite, the negative. Okay? And we can tell which direction a cross product will point using what's called the right-hand rule. Okay, so let me show you an example here. So if this is vector u and this is vector v, and this is vector u cross v. Okay, and this is vector v cross u, going the exact opposite way. Not surprising, since we know the principle of anticommutativity. The trick here is, how do you know which one goes which way? How do you know which one is u cross v and which is v cross u? So you could tell using the right-hand rule. So if I have two vectors, let's say we're in three-dimensional space. I have two vectors. Let's say, let's call this vector u. And let me draw it a little differently. Let's say this is vector u. And this is vector v. Okay, you can tell which way the cross product is going using the right-hand rule. If you imagine your fingers curling through of your right hand, curling through the first vector first, and then through the second vector, your thumb will be pointing in the direction of the cross product. All right, so imagine your fingers are going through the first vector first, and then through the second vector. Okay, your fingers of your right hand, then your thumb goes in the direction of the cross product. So in this case, it will be going up. And it would be orthogonal to both vectors u and v. If your fingers instead went through first v first and then u, your thumb would be pointing down. In that case, your thumb would be pointing the other direction, and that would be v cross u, because your fingers would be going through vector v first. So let me summarize that in writing. The right hand rule. If you curl the fingers of your right hand first through vector u, then through vector v, your thumb will be pointing in the direction of u cross v.